Good morning, everyone. Let me share my screen. Now you should be able to see it, yeah?
Yeah, we can see it perfectly.
Okay, cool. So welcome to my presentation. As Joritza said, my presentation is about educational materials on computational tissue engineering and a solution that we have developed in KU Leuven. So the introduction would be like, a recap on reproducibility, that reproducibility matters a lot in today's research, especially in computational sciences, that people should be able to reproduce the results to increase the transparency and also increasing the outreach. But then the question is, what for education then? Because the same concept can be applied to education, and it can be used to create open source interactive educational materials that can address the challenges of creating more fun and more comprehensive materials for students and the people who want to learn the concepts, especially, as I said, in computational sciences. And the challenge for redistributing the content that are created and copy them, and also it can be the starting point for developing further materials that are not necessarily the same, but they are similar enough. The solution to this, one of the best solution at least, is taking advantage of a platform, a software that's been developing for 2 decades almost, called Jupyter. And Jupyter is a killer app, if you know the concept, for interactive computing. Means it provides an environment that you can provide the code, the computational stuff, beside the supporting content, such as the videos, the audio, the images, everything, and also the description. So it's different from traditional concepts that you provide some documentation, some tutorials, let's say, and then the students and learners should follow the tutorials and then run the code separately in another environment, and so, or run the simulation code somewhere else. That's why it's a killer app, actually. And it eliminates the complexity of getting started, because this is actually a big issue, that people need to install some stuff, and then they need to set up their environment to get started with these tools. And then it also provides interactive classrooms, the opportunity to have interactive classrooms for faster learning. And as a bonus, this is not very important, but it also provides some features to have interactive assignments in comparison to traditional teaching assistants. It's a bit different, so you can have assignments that are, they are self-explanatory, and they can be even auto-graded. And I can say, especially in the field of engineering, there are a large number of Jupyter notebooks already developed in a term of full course, that you search for a concept in computational engineering, and you will find a course developed by someone, and is being made available by someone on the internet. You can grab it and you adapt it to your course. And as you can see, it can be adapted to classrooms with many students. In this case, this is UC Berkeley. The lecturer is running the Jupyter notebook, and the students are following her on their own laptops, reproducing the same thing that she's doing, actually, by following the contents. And just a couple of examples. As I said, there are lots of examples, but these are just to demonstrate how it looks like, how Jupyter looks like actually in action. So, for example, in terms of basic physics, as you can see, you have the code. This is a notebook. And then you have the code, and beside the code, you have the documentation. You can have mathematical equations, and also the images, videos, everything. And this is, for example, for chemical process control. Again, mathematics, codes, and the results. Students can easily change the parameters, play with the parameters, and play with the variables, trying to find out the logic with the help of the supporting materials. And this is, for example, for quantum mechanics course. This is really a very comprehensive one. This is from chapter 10, as you can see in the title. So people are really converting the full course, the courses that they're teaching, into this kind of materials, and they put it on the internet, and you can easily grab it and you adapt it to your needs. And what we have done in this case is we have developed a set of Jupyter notebooks for of course in tissue engineering that is related to computational mass transfer, and they are accompanied with the prerequisites, so the students can follow the notebooks. In this case, these two notebooks that are sort of introduction to Python and kind of computing, and then they can also follow the rest of the course. So everything is provided actually. And as I said, this is initially developed for the mass transport and tissue engineering course taught by Hans. It was taught in last semester, but also it will be I will teach it again in 3 weeks, a bit with a little bit of change. And everything is available freely on GitHub. So students following the course, as well as everyone else, can access the materials online to run them. And this is actually something that they can run locally with installation guide, and also checking installation, everything is included. But also there are some online services, hosted services, that students can use to run the notebooks online without the need to install anything on their system. And what is included in the course is like kind of problem-solving approaches. So for example, mass transfer and cellular constructs or other kind of scaffolds, and then they are accompanied by equations, step-by-step tasks, and then the codes that they can run to do all the manual steps automatically using symbolic computing, as well as numerical computing for the students who are more interested into the topic. So in this case, you can see that they can change parameters, they can play with some of the concepts that are well known in numerical methods, and they can see it in action without being involved in the complexity of getting started. And all the recordings, all the accompanying materials, including some videos, as well as the recorded session, are also available on YouTube, and they are referenced in the GitHub repo, so people can access it easily. And then what we do also with Jupyter is we publish the building blocks of our research. Actually, Jupyter allows it that you can, in order to increase the educational value of every research, you can publish part of the research in a reproducible manner, in a way that people can look as tutorial at via Jupyter notebooks. And in this case, we've done it for example, part of our research that is related to parameter estimation. And then we have created a notebook that states how we do that and how people can reproduce it in their own research, or if they want to learn it, or they want to teach it in a session. It's easy to be followed step by step, even for self-learning. And as a final note, I can say that that I have started recently a collaborative project, a project that I hope that people will also join me to share experiences on computational tissue engineering using open source tools. This is actually a YouTube project, but what I want to say that is related to this presentation is I heavily use Jupyter for educational videos, that when I want to teach something, when I want to demonstrate some concepts, especially if they are mathematical or related to the core numerical techniques, I heavily use Jupyter to demonstrate the concepts so that people can easily follow the videos, but also they can take advantage of the notebooks later on for their own, or they can use it in their own educational courses, let's say. Yeah, that's what I wanted to say. Thank you so much for your attention.